All right. So we were seeing about the database architecture in the last class. So what we saw, just to recap, we saw that the database has a database and an instance. The instance is the memory structure, and database is the disk structures. And we can have more than one instance, and a single database can have more than one instance. Just give me 1 minute. Yeah, guys, sorry. So we have an instance and a database. A database can have multiple instances. That is what was told. And one operating system or one server can have multiple database installed in it, depending on how much resources we have on the server. Always the cylindrical form, whatever we see here means a database, which has an instance and storage, which is also called as a database. Right. So this is the architecture of the database. We will slowly be seeing each and every part of this, all this processes and memory components over here. So first, we'll learn about database instance. Here, the bigger box which we see is that instance. This is basically a memory structure. So first, we'll read about this instance. So this instance gets created when you start the database. That is nothing but the memory being assigned, and as the database starts, it takes a chunk of memory, which is mentioned in one of the files, and then it creates smaller parts of the memory, which is basically the shared pool, large pool, library cache, all those things. Right. Um, we have something called as SGA. We'll see that later on. Oracle System Identifier, or SID, is basically it is the database name. Every database has its name. That is how you can differentiate one database from another. Same way as every server has its name, which we can find out using the command called as host name. Every database has its name. And again, to get any information about the database, you have to go with the SQL queries. There is no other way to get out the information about the database without SQL queries. So this is just a comparison between single instance and Oracle RAC, multiple database instances. It's like having two different servers to access one database, just in case one server breaks down, the other server is always available. Then we have read-only mode, uh, where database will not allow any changes to be returned to the database. It will just be in read-only mode, where this kind of mode is used for a specific type of activities, which we'll be seeing later on in our classes. But for now, just remember that there are two modes: read-only and read-write mode. And this is how the database starts and shut down. When it start up, initially it's like in a shutdown mode. Then it comes in no mount, where just the instance is started. Then comes in mount mode, where control file is open, then the database is open. When in mount mode, only DBA can access the database. And while shut down, again it is in open mode. Then the database is closed, then it is no mount mode, and then it shut down. Okay. So then we were seeing about the database logical structures. So what are the logical structures in database? So on a higher level, all the structures in the database are broken down into physical and logical. At the physical level, we have this data files, and at the logical level, we have something called as Oracle data block, extend segments, and table spaces. OS block is also a physical structure. OS block mainly it's at the operating system level, so it does not fall into our study over here. Data block is the finest level of granularity. Uh, Data is stored in the data blocks, and the size of the data block can be determined by a parameter called as db block size. So there are few parameters which define your database. So I'll be noting down the parameters as we go ahead with the class. That way I can send you the list once we have. So first one is database block size. This will give us the smallest granularity of the data in database. So database block size is at the database level. So if anything, how much minimum data can a database access depends on this DB block size. So this can be 8 KB, 16 KB, 32 KB, 64 KB, 128 KB, etc. Okay, this goes on. So you can set this to this parameter to any of the value while creating the database. After you create the database, there is nowhere you cannot change this block size. So when you are creating a new database, you need to check with the application team. Generally all the application provide a document where it will say like what kind of block size of database is required for the application. This will be provided to you by the application team. So in that you have to read the document and find out what are the database requirement. All the database requirement, this one will be one of the requirement. And we saw how the data is stored in a data block level block header, where information about how much of block is full, how much of block is available, that information goes in block header. Then we have something called as table directory. In table directory we get information about the data in the block belongs to which table, that is goes in a table directory. And then row directory is the empty space where the data is filled. Then a group of blocks makes extents, group of extents makes segments, group of segment makes table spaces, and a group of all table spaces make a database. So that is how at a logical level the hierarchy is. Now since we discussed about the logical structures, I thought let me change the way I generally do the uh, explanation of all the components of database architecture. So I will be doing the physical structures so that you have a comparison between the logical and the physical structures. So this kind of takes us to the physical to the database level. Let me show you. Yeah. So physical files exist in the database. So we are coming out of the instance where it's all about the logical structures. Now we are coming into the database where we have the physical structures. So let's see what all are the physical files which are available for us. So physical storage structures are nothing but the files which are visible to us, which we can access, and which we can access in the sense we can access at the OS level. And the files which we cannot access at the OS level, those can be termed as a logical structures, right? So few of the physical storage structures are like data files, control files, online redo log files, archive log files, parameter files, backup files, password files, alert log and trace log, and few of the other files managed by Oracle. So all this fall into the storage level. So if you see here, database instance is the memory level, and all this are at the storage level. I'll just show you those files here. Terminal. Don't worry about all the commands I am running uh, so fast. You will slowly gain the speed. Okay. So these are few of the files, physical files, right? This is .dbf means data files. All these data files which you see, sysocs, system, undo, tbs, temp01, user01, these are few of the data files which get created on the database by default. Once you install the fresh database, irrespective of what application is being used, what is being done, the base database has these five data files. And then we have this redo logs, redo 01, redo 02, and redo 03. By default, always at a minimum we'll have 3 redo logs in a database. Why 3 redo logs, we will see today in today's discussion only. But redo logs by default is 3. Then we have control files. This is it's always better to have multiple copies of the control file in different locations, because just in case this is where the current control file is. Okay, in mount point. Okay, do you guys know about mount points? Any idea?
No.
No. Okay, so mount points, like in Windows we have drives, right? C drive, D drive, E drive, F drive, whatever. So that way, on Linux, we have something called as a mount point. Similar concept, drives, mount points. So these are different mount points, slash dev, slash shm, slash run. All these are different mount points. Now, we don't really mount this file systems or mount this mount points. That is the work of the storage admin, but we are just going to use it. So when a new server is provided to you, you will be asked to give us the amount of space required for the database. Now, from where will we get this information, like how much space is required? Again, the application document which comes to you from the application team will have that information, like, okay, we want a database which has so much of space available, like 100 GB, 200 GB, or 1 TB, whatever, depending upon how much data this application will dump in the database. All right. So here our database is installed in slash home mount point, in which is of size 92 GB, in which we have used 51 GB of the space, and available is 42 GB. In whereas in Windows, what we do to find out this information, say we have C drive, and here it shows 128 GB free from 464 GB. And to get the permissions and everything, again you have to right click and go over here. But here again, permissions are not displayed here, but the names and everything, how much is used, all those information is here. So mount points are similar to the drives, C drive, D drive, whatever in Windows. So that is a mount point. So our database is installed in this mount point slash home. Okay, so here we have this data files. So we kind of got distracted from this control file. So control file, it's always recommended to have 2 copies, probably one in slash home and probably another one in slash dev or something like that. So what happens is there might be some scenario where this mount point might have some issue, some corruption at the storage level or something. In that case, our important file, which is control file, if we have a copy of that in a different mount point, we have a safe copy and we can start the database and restore from the backup. So these are the physical files which we will be talking about. Okay, data files, control files, on and redo logs, archive logs, parameter files. We'll see all of these in details. I have separate chapters for each of these files to understand what exactly it is and what they do, what information they carry. This architecture class is basically just for a brief idea of each and everything, just to understand how things go around. So first, let's see what is a data file. Every database has one or more data files. So when you create a database, by default, we get something called as a table space. So table space, I'll keep this for parameters. So table space, what is a table space? Table space, you can say like it is a logical structure. Table space is a logical structure to group the objects belonging to a specific user. Okay, if we have a database in which, say for example, I created a user called Dave, then once my user is created, there is a table space also created for my user account. So whatever objects I create, whatever tables I create, index I create, all those objects go into the same table space. Say for example, I create a user is Dave. So table space can be something like, for example, Dave underscore TBS. Okay, just to know that, okay, there's a table space and the user is there, right? So table space, and in this, all the objects which I create when I log in as my user Dave to the database, all those objects go into this table space. Okay, so that is the table space. So in this table space, we have physical files called as data files. So all the data goes into the data files. Okay, so to just explain you in a pictorial way, let me try to take an Excel sheet. Say for example, this is our block size of 2 KB. Okay, so we have so many blocks of 2 KB each. So there's like 10 KB, 1 2 3 4 5 6 7 8. So this is 100 KB of space which we have. So 100 KB of space. Say if I create a user called Dave, and I say that Dave user will have a table space which is of 100 KB. All right. So what the database will do in the backend is it will go and select this 100 kilobytes of blocks. Assume every block over here is every cell over here in this Excel sheet is a block, right? So it is going to go in the storage level, and it is going to select this 100 KB of blocks, and it is going to create a data file with this 100 KB. So this outer, the whole selected box will now be a uh, data file for me. And this data file is a physical file. Okay, this is logically kind of uh, mapped to the table space which is created for that user, dev underscore TBS. Right? Is that clear? Any questions here? Mukta, Suchitra, any questions?
No.
This kind of an important concept. You need to understand this better.
Yes, Sajjad.
Okay. So set of blocks is selected and a data file is created. Okay. This data file belongs to a logical structure which is called as a table space. Okay. So this is what happens when a table space is created in the backend. So data files are part of table space, and table space is part of the database. Okay, in data files, we have different kinds of data files. One is permanent data file, where the data which is stored in the data file is there permanently. It is not temporary. Second one is a temporary data file, where the data remains only for the duration of a session. Say I log in using a user, say same user dev. I log in into the database. Now, once I log into the database, I have access to all the objects in my table space. Say I want to update the one of the object in my table space. Say there is a table called as employee table in my table space. Employee table is there. So I want to update this employee table. So I will pull out the data of this employee table. I will, in the sense, I will write a query which is going to pull out the data in the employee table, and it is going to change that data for me. Now, once this data is changed, that data is called as a temporary data. It is not a permanent, right? And this is just for the duration of the session. Now, that login which I did to the database, if that login is logged out for some reason, power outage or my terminal got disconnected or something happened, my internet is down, something happened, and this login was cut off, then this table which was temporary entry, the update which was there in the temporary entry, that is gone. That would be a temporary data which is gone, but the permanent data, the permanent copy of this employee table which is in the data files, that will remain same. So when I say the temporary information, that is the information which goes into the cache, right? So there is a mechanism which happens behind the scenes. Actually, what I'll do is I'll explain you guys that architecture once. I know it's a little bit difficult for you. Um okay, so let's I'll tell you the architecture at a high level. That way, it will be easy for you guys to understand what I'm telling. So this client process is a login from, let's consider Bank of America website. A login into a Bank of America website. You are logging into a Bank of America website, and this client process connects to the database. Now this instance is the database instance. Once this connection happens, there is a small memory which is allocated for your session, which is there. The session small memory is allocated because we have to keep some information like your user ID, password, into that session, so that we can authenticate that you are a valid user or not. That happens here. Once that is done, this connection is authenticated and you are in the database. So once that is done, the next command comes, like what exactly you want to do. You want to do a transfer, for example. You want to transfer some money from your check-in to your savings account, right? So when you initiate that process of transfer, what happens is this processes which are there, all these processes, they are doing some work behind the scenes. So what they do is they go to the data files, to the table space, to the block level, and pull out that information from the data file and dump it into the database buffer. Now this is a buffer cache, like it's a temporary thing. So that data is dumped into here. Now next process comes in and checks what exactly has to be done. Should I make a transfer? So here it will pull the data of your check-in account, your savings account. Now the update has to be done. So it has to reduce your say $1,000 from your check-in account and increase $1,000 in your savings account. So that changes are done here. Now when you say, okay, confirm this transfer in your Bank of America, when you say confirm this transfer, so what happens on the database is all these changes which are there, those changes are written back to this data file in an updated manner, right? So this database writer process, it kind of reads that information into buffer cache, and once the changes are confirmed, it puts the changes back into the data file. So when this data is there over here in the cache, it is temporary data. When if your session, the login session for Bank of America fails, then all this information is gone. So your changes did not happen until you hit confirm. If you hit confirm this changes or confirm the transfer, and then if the power is turned off or you logged out of the session, then those changes are already there in the database, right? So when I say you turn off your session, your connection to the database is gone, right? And the information will be there in a buffer cache. So sometimes you will see that you'll get an email that your transfer is half done from Bank of America website, or your transfer did not go through. That is because the database figured out that there was a transaction which was happening in the database, and that transaction did not complete, and the transaction was left halfway. Same way, for example, if you are doing shopping on Amazon or Walmart or any other website, your session is logged in and you added some something in your shopping cart, and that information in the cart remains in the cache, right? Once you confirm the order and check out, then all those order details are goes down into the data files where your user information exists in a table and the table is updated there. So temporary information means all this temporary information here, permanent is down into this database. So at a high level, that is how database works. And this is something called as a redo buffer. We'll see this in few minutes.
So then when the connection to the database is abruptly failed, so
Mhm.
do we get any acknowledgement like while we develop this code, we get these exceptions, like the code exceptions will come like this is not happening, this is something went wrong, that's why it's not executed. Will the DBA receive any acknowledgement from the database like this is not go through? Like for a
Yeah, see,
hypothetical purpose, we will get a acknowledgement. The pop-up window will come. Yeah, this is not go through. That's fine. But what is happening for a DBA? Like,
at a DBS perspective, see, whatever happens on the database, everything is recorded some other place. Changes happening is recorded into this redo log buffer, and there is also something called as a alert log. We'll see later. In a alert log, all the errors, all the changes, what all is happening, what all statements you ran, everything gets recorded over there. So if something fails, when a developer is doing something failed, yes, that error is recorded into the archive log. Sorry, that error is recorded into the alert log. And if developer says some error occurred, then DBA will go and log into the database, check the alert log to see what error occurred, and along with the error it will give us more details which will help us to understand the error. And depending on your skills, you can uh, fix the issue accordingly.
and this database buffer cache memory is there, right? This cache memory again, like how long will it stay and all. This is not our call. The developer will take care of it, right? Or
No. Buffer cache, all this whole thing is your department,
because
DBS department. So this buffer cache and everything, it will stay until your database's instance is running. Once you do the shutdown database, that is when this is going to clean off completely.
okay, got it.
Yeah. So going back to the data files, so permanent data files and temporary data files are there. Uh, and then we have control files. So control file is kind of, you can say, the uh, mind of the database, where all the information is registered over there. Your database name, your number of changes happened into the database, what is the change number of a database, and all this information is dumped into the control file. Every time a database starts, it first checks the control file to get the basic information of the database. If a control file is corrupted, control file is not accessible, your database will not start. There are ways where you can create the control file again if you have all the required details, but always control file is very important. Take backup of the control file, make copies of the control file, keep that control file information handy. That way, any issue happens at disk level, somebody deleted the control file by mistake, junior DBA deleted by mistake, they don't know what they're doing, then you know what to be done, and you can get the database back up and running, right? So if control file is gone, your database is gone. Okay, you cannot access the data. So very careful file, very important file, be very careful. And most of the times it is referenced by .ctl. uh, Depending on the DBA, they might want to name it in a different way, but .ctl means uh, ctl is like control.ctl. That is the format it is registered in. Then we have, okay, what are the contents of the control file? We have database name, the timestamp when the database was created, name and locations of data files. Where are the data files? Where are the redo log files? How many table spaces are there? How many redo logs are there? What archive log information? We'll come to archive log later. It's a little bit confusing concept. Archive log information. How many backups are there? How many backups of a data file, how many backup of a redo log file, how many data file copies are there. All that information is dumped into the control file. So we will, once when we come to the control file chapter, we'll go through this everything in detail. For now, control file is very important file. Most of the information of database is registered over here. If there is no control file, you cannot start a database. Then we come to the redo log file. Redo log file, every database has to have a online redo log file. So what exactly is registered in this online redo log file is, so I'll explain you here. So what happens is, we have a process called as log writer, LGWR, log writer. So log writer main responsibility is to write down what all is happening on the database. So it's like, if you kind of consider a old, let me get the charger. Okay, so giving an example of the log writer, right? Log writer is like, in an old uh, banking system, where each entry was kind of registered in a book, right? You had a passbook, and every entry you do in the passbook is like what you did with your account. Did you deposit anything? Did you pull out some money out of your account, or you earn some interest? All that is kind of written into the passbook, right? Just a minute. So same way, log writer kind of enters all the information which goes on into your database, like all the changes happening. If any data file was changed, any table was changed, any data file was added, any data file was removed, any new table space was created, any user was created, all this information is kind of written into this files, which is called as online redo log files. Where are these online redo log files? These are the online redo log files: redo 01.log, redo 02.log, and redo 03.log, right? So these are the online redo logs. So why do we have three online redo logs? Because these changes which are being written, these are very important. Why is this important? Just in case if something happens to the database midway, say some changes were happening and suddenly database crashed because server crashed, or there was power outage, something happened. In that case, the changes which are written into this online data logs can be used to recover the database until that point of time. So all the changes which you made to the database need not be written into confirmed over here, right? So you are making some changes, only half of the changes got confirmed over here, remaining half is still there. But this redo log buffer has those changes in it, and the log writer process kind of wrote those changes in this redo log, online redo log files. So in that case, even though we don't have the changes, but still we have the information, like what was changed. Was some money transfer from checking account to savings account, for which user, from which account number to which account number? All those details will be registered in this log writer. So in those terms, it will record everything in this redo log. And for some reason, if database crash, this whole instance is kind of refreshed, nothing in here, still we have the data in this online data logs. So we can use this data and recover the database until a specific point in time. Okay, we'll come to that point in time recovery and everything later on. But redo log, what is the use of the redo log? Redo log uses to record the changes happening at the database level.
But
All, yeah.
but Dave, isn't it a drawback of having like three redo bags? Doesn't it takes lot of memory? Like just for a small Bank of America application, if we have like this, there are plenty of things, right? Then isn't it a
Yeah,
kind of drawback?
see, yeah, yeah. I'll come to the point, right? So why three online redo logs? So log writer is writing in this one. So this redo logs are not really so huge in companies where too much of transactions happening. That is huge, like 1 GB or anything. But generally, this is probably 100 MB or something like that. And this is not at the instance level. Okay, redo logs are not at the instance level. Don't confuse with the instance level. Your redo logs are here in the storage.
Mm-hmm.
Okay, not here. Your read log buffer is there. This is the temporary space. So changes recorded over here are read by log writer and written into this one. This kind of a physical file. So say log writer wrote into one online data log, 100 MB of online data log. Now this changes. There is a new. There is another feature where these changes can be archived or these changes can be saved. So in that case, what happens is when this online data log file is completely written, then log writer goes to the next online data log file. By the time it is writing the second one, the first one is backed up, right? And similarly happens. So we can have two, but what if the backup did not happen until it's finished writing the second one, right? So that's why we have a third one. So the session is kind of ending now. We'll log out and join again. Okay, I'll continue there.